But what we got here, really, if we go to the next slide, this is just a high level overview of our VPCs. We've got three that we configured in one of the other videos. And really, our security VPC that you can see here on the left, we've got a pair of Palo Alto virtual firewalls. We configured the second one the other day. I did that one offline that basically mimics most of what's here on the left. And then to the right, we've got two virtual private clouds or VPCs. And we decided to just deploy two new servers. So just a simple AWS AMI Linux box there. And we put one of them in availability zone. We should have changed this to 2A as well as 2B here. All of their traffic goes across the transit gateway. If they need to get to the internet, it needs to come right now through the security VPC. This is the only VPC that has an internet gateway attached. And what we're going to do in the end is, even when test wants to communicate with prod right now, it directly goes to the transit gateway and then it knows how to reach this side or here and it forwards it, basically bypassing our firewall. But for our east-west traffic, we really want to do that traffic inspection. So that's the goal of today's video. So what we see here, again, speaking high level, we see the word necessary here. We got all of those VPC transit gateway attachments in a single route table. And that again, the behavior of the traffic forwarding that we just described, the ability for one VPC to basically go directly to the other, to be able to influence these routes, we need to split those VPC transit gateway attachments up. And so we'll come back here and deep dive here in a bit, but to keep the ball rolling, we again won't go into too much, but again, I said I'd give you a preview. So we see here that our intended goal is, when the server in availability zone 2A does a ping to this Linux box over here, it's going to, of course, hit that transit gateway first. And then once it hits that transit gateway, what we want to do is send it to this security VPC. So that's that splitting of the route table. We're going to force it to basically go there. Again, on the next slide, this is where our gateway load balancer endpoints come into play to influence that traffic and to ensure that it's inspected across the third-party security appliances that we're using, which are our Palo Alto firewalls. That's where we see here in the next slide. We've got a big question box there. I know, a lot of you might be wondering, what the heck is that? So now that the traffic's made it into our security VPC and lands on that transit gateway attachment, it's, again, once we configure this gateway load balancer that has the ability to load balance traffic, keeping the symmetry across a pair or even more of these firewalls, that's basically going to be where, here in this question mark, we need to match a security rule that basically is going to permit or deny traffic. And so that, again, is going to be up to us. And so that's the name of the game today. I'm trying to change the box back. Let's see if I can uh, get myself back on the screen. Let's see. There we go. So that's the name of the game today. And then again, we'll go ahead and escape out of there. And let's pull up. See, we got our notes over here somewhere. Again, shout out to everybody, like we said, that's hanging out with us here on a Saturday. Probably hoping to do this all in just a nick of an hour once we start configuring, to be able to slow down, demonstrate everything, and to answer any questions. But again, slow on the sticks here today. Let me pull this up and see if we got any chats. No chats just yet. But again, thank everybody for joining. So let's go ahead and go full screen and zoom in. So what we've got here, again, we like to always properly plan. Again, even if we don't get into the finite details, if this was production, we definitely would get this approved by our change review board. Hopefully we'd have a proof of concept, or we demonstrate or configure this in a dev environment before we took it to production, if this is a new type of solution. So these are the high level steps of what we need to do. And I promise you, got about a minute left before we jump in and start configuring. First, we need to create that gateway load balancer and the gateway load balancer endpoint subnet. So we need to pick 4. We need to pick 4 subnets. We'll probably use this as our scratch pad as well. Let's go ahead and prep that. Just press enter, and we'll just say notes down here. And this will be kind of how I like to do it, and Notepad. All right, we'll zoom out just a wee bit. Then next we need to basically create the route table and associate those subnets. Again, there are times where you can combine, like say for these firewall management interface, where the only traffic that we care about is ourselves basically coming across on 443 to basically get to the web console. We can combine both of those subnets into one route table, but typically when we're doing things like this, what that may catch you up in the future is if you need the management AZ1 to route traffically differently. Now that they're bound, they're both going to inherit those routes there. So that's why we like to keep it separated. And again, we'll slow down and explain what we'll do there. Next up, we're going to first configure the target group that basically is, I won't say the destination, let's just call it the arm across the gateway load balancer. It's going to say, what are we targeting? Same with an application or a network load balancer, basically the back end. And we're going to basically target the inside interfaces of our firewalls. Going to configure the default health check rules. We won't go into depth about the Geneva protocols, port 6081, but we'll see that that's an option once we get in there and configuring it. And then we'll go ahead and configure that gateway load balancer. And the reason I like to create the target group first is because one of the selections you'll see in there is to basically pick the target group. And so I like to do it that way. Next, we need to, of course, to get the health checks to bring that up. We'll see it's unhealthy. It'll go from registering to probably unhealthy at first. But again, I'll run through these again. Like I said, we just wanted to like show a visual for the folks that are dropping in that probably they may have a clue at what we're doing. They may have never seen a firewall or etc. So we want to kind of establish a baseline setting. And again, we just demonstrate and show kind of this PowerPoint that shows the visual. But without further ado, let's go ahead and get to configuring or at least planning like we noted. We need to first pick up or pick out these subnets here. So I'll bring this here over to the side. All right, so let's first go into our VPC, and this is going to be 4 subnets that we need to create in our security VPC. That's, of course, this is the entire CIDR range. Each of these VPCs is a /24. So we'll come to subnet. We could pick security, but we can probably eyeball this. Let's see. We'll sort ascending, and let's carve out some space. So AZ1 ends at 48. /28 is, of course, again, test for you out there. How many IPs, usable or not, is this? And this is the magic number for me. I always start with 28 times up, but it's 16. So we got 16 there. So we'll bring this here and probably zoom in a bit. And so the next one up, if we were to do our addition, is going to be 64. So we'll name this one security gateway load balancer, and we'll call this AZ1, and we'll call this security gateway load balancer AZ2. We'll go ahead and paste that, and let's just add it may be hard for some to see, but we'll add an E to the end. We'll be careful because that can be kind of a stickler if this was production, but this will be sorry about that, 10.0.0.64/28. And let's see, next up for AZ1 down here, plus 16 to the end will be .80/28. And then, of course, for AZ2, likewise, if we came on down, we end at 176. So we're going to add 16 to that. 16 plus 176 is 192, I believe. And we'll just keep going for our fourth and last subnet. Plus 16 should be 208. Again, we'll get an error once we go in and configure it if we're wrong. All right, so let's go ahead and create these subnets. We'll hit click create subnet. We'll select our VPC. These, of course, are going in the security VPC. And then we'll go ahead, and what I like to do is just add subnet 4 times. And what I like to also do is go ahead and I do AZ1212 so that I can copy and paste the name. So I'll copy the names first. We'll do that AZ1, and then we'll backspace and put 2. And then we'll just go ahead and keep 1 and add an E for the endpoint subnet. And we'll paste this again, backspace to 2 and add an E. Then we'll go ahead and pick the AZs. Again, this will be availability zone 2A. Again, we we typically deploy in the US East. I forget in the summer why we elected to put these in US East 2, which is in the Ohio region. And then of course we need those CIDRs, so we'll just copy and paste there. We'll come up, make sure we're under subnet 1. All right, we're good there. And we'll just change this to 192. We'll change this to 80. And again, big shout out to anyone that's coming in right now. Like I said, first live stream on the channel. Just looking to have a good time today. Do this, want to go live a bit more. So again, if you subscribe to the channel and you basically leave the comments down below. This video today, this idea really came from 3 comments over the last 6 months. And I said, it's better to just go ahead and go live, configure it. If we mess up, we'll troubleshoot and just to see how it goes. All right, so we got those subnets. If we clear our filter and we see, there we go, we got that small e. Next up in our list was really to create the route table and associate it. So the thing about route tables, unlike you saw, we created 4 subnets in one step, is that we have to come back out. But let me think. I think we need 4 route tables because our transit gateway needs to point to a different endpoint. We could combine it, but we'll let me see. We'll do it the way I would do it in production. So let's go back out and we'll copy one of these. We'll create a route table, backspace there. So for our gateway load balancer, technically they both are going to have a local route. They only need to route traffic to the inside interface of the firewall and not a specific NIC because it's going to be load balancing. So we technically can associate both of those here. So we'll do it in one step. Instead of going back out and creating the other route table, we'll come to subnet associations. Here at the bottom, we see that there's 4 that don't have any association. So we want to associate the 2 that are, of course, without the E, but we need to hit edit subnet associations. We can filter if our eyes play tricks on us and filter again. And then we'll just select both of these and we'll save the association. So for the route, we don't need to edit anything. Again, we'll keep it moving there. So we'll click route tables and we now need to put the endpoints in their own route table. So we'll call this, we'll actually copy this -2A, -2A, -2A. So we'll create one for the endpoint security. We'll copy that and just put a B at the end. All right, so we'll put a B. We tried to do some cleanup, but we see that we're not consistent between the 2 B, like, we naming convention and things like that. All right, so let's go back out just so we can all see it. Again, we're going a little bit slow today, just because I think it's a little bit easier to keep up with. But thanks again for everybody joining in. If you're just joining us, we're configuring the Gateway Load Balancer. We did a high-level overview of where our environment was before, a 3 VPC architecture, and kind of an end goal or what we hope to achieve. Fingers crossed again. All right, so again, for the 2A, we will basically do subnet associations, and again, we'll do filtering, and then we'll sort, and we'll pick the AZ1 with the E on the end for endpoint. And we'll come back out, we'll pick the 2B, likewise, subnet association, and we'll do the same. And we'll pick the one that, of course, is AZ2. We'll save the route for when we create it because technically we need to forward this to some resource that doesn't exist just yet. All right, cool. Well, actually, not for that one, but we actually will explain all of that down the road. But again, let's move this out of the way. And let's bring our notepad back up. So if we had a scratch through, I know I could use VS Code or something else, but what we'll do today is we'll put an X in front of the step that we've done. All right, so we've done those. Next up, we want to create that Gateway Load Balancer target group. All right, so for that, we got a tab. I always like to keep a tab of EC2 service and one with our VPC. So we need to go back to the EC2 service. And if we scroll down just a wee bit, we've got load balancer, which we'll come to next, and target group. So open this up in a new tab and we'll hit create target group. And then this is where, again, they used to, I mean, AWS came a long way. None of this color coding or helping was really here, but this lets you know based on what kind of load balance you have, which one of these options are available. Like 3, 4 years ago, you could only target the instance and you'd have to like swap some interfaces. It was a mess. But what we want to do is basically pick the IP address, and this is where when we register the target, we're going to select the inside interface. So our target group name, we'll call this one, we'll keep it lowercase, Palo Gateway Load Balancer TG for target group. And then for protocol, that's where, again, we won't go into too much depth, but this quote unquote special protocol, the Geneve that they, the Gateway Load Balancer knows how to speak, this encapsulation, this overlay protocol. You can see it says it's used with the Gateway Load Balancer. That's going to change that port to 6081. And then, of course, for our VPC, we're going to put this in the security VPC. For health checks for today, we'll leave this at TCP. Advanced health checking, we're going to have to open up port 80 and we're going to have to do something else as well, but we'll cross that bridge when we get there. And I always like to, at a minimum, put a name tag. We saw when we're creating a lot of the other items that it automatically added that, but this is not one of those places. So next up, this is where we register our target. And again, we said we're going to use the two inside interfaces. If we go back to instances, and we can highlight, we can do it in any order, but we'll go A and B. Go to our network tab. ETH1, our index one as well, is our inside interface. So we'll copy that. We'll come back over. Actually, we just need to put in the last octet. We'll add the IP4 and we'll do the same for our second firewall. We see 150 is the last octet there. And then we'll just go ahead and include as pending below. And we see that we got our two targets there as a part of this target group. So we'll hit next. And this is kind of like a last step overview of reviewing. In a production environment as well, you definitely wouldn't want to keep this as version 1, but we're all good in the lab here. All right, cool, cool. All right, so this, I'm not gonna lie, is gonna take some while, but first we of course need to attach this target group to a gateway load balancer. That's why you see the status is it's not configured to receive traffic. So our next step, again, we'll cross this one off, is gonna be to configure the gateway load balancer. And there, again, just for everyone's own edification, there's multiple ways that you could do this. We can put endpoints when we get there into each of what we call the spoke VPCs, but as you can guess, that would only increase the cost. So we'll keep the concepts a little bit simpler, as well as for this lab account, we'll keep the cost down a bit. All right, so let's hit create load balancer there. And next thing up, what we're going to do is we're going to create a gateway load balancer. So we'll hit create. I think we named this one Palo Gateway Load Balancer -TG for the target group. Network mapping, of course, this will be security. And let's see, let me pick this circle thing. Oh no, that's terrible. All right, we'll keep it a square. Sorry. All right, so now for availability zones and subnets. Oh, it's been a while. I'm trying to think. I know I need to, that's the endpoint. We need to do, did we do the 2 at a time? All right, so that'll be there. All right, so we'll pick our gateway load balancer subnet for each, and hopefully we get this right. Not the endpoint. That's for traffic inspection. All right, so we got that there, and we just created those subnets earlier. If you came in, we needed to pick. We need to create 4. This is where if you did the gateway load balancer before the tar group, you would have to create it here. It would open in a new tab, but we've already created that. So we'll just select it from the drop down. Tags, likewise, we'll just do name and Palo Gateway Load Balancer, and then basically a review if you want to do that, but we'll go ahead and hit create. And so now if we come back to, I don't, we might still have it in this tab. So now if we refresh this, we'll see that the target registration is in progress. But to be quite honest, it's gonna fail. And the reason that it's gonna fail, or one of the reasons, is if we go back to our firewalls that are, for the most part, they're not pre-configured, but we've been using at least this first one and prior labs. And let's make sure, I normally put A on the left, so let's move this one here. All right, but the reason is because if we take a look at our security rules, all that we were doing in those previous videos was ensuring that we could SSH into those. We had Kali Linux and we had Juice Shop, two different, it's a vulnerability type of server or application, or container, I should say. But we basically overnight, we decommissioned those and we just stood up two simple test Linux servers. And the hit count is just, we just tested that we could SSH or confirm that we could get to. But we don't have any east-west traffic like one VPC that came across or even our inside interface, like there's no communication there. So first we do need to create um, kind of like an east-west rule. Let's see, what step are we on? Well, that's the next step. So let's create those. And again, in a production environment as well, you'd have an inventory of like your IPs, but you'd want to kind of lock this down. But for the purpose of today's video, we'll be a little bit loosey-goosey and we'll call this permit uh, internal LAN traffic. I like the term east-west, but some people think that that means like the east region to the west, which it technically does. So I'll just call this rule something different. And any coming from the zone, we could add technically, since we created an object group, all the VPCs will do the same. It's private to private. And because we don't need to NAT anything, we don't need a NAT rule. We'll permit any, although we're, for the most part, probably just going to do pings for the purpose of today's video. So we'll hit OK. And then we need to, of course, or we don't have to, but we'll move this above, make it rule number 3. All right, one other thing that we need to do as well is we're permitting HTTP, but what I like, this is step, technically I don't know if you have to do it. We'll do it, what we'll do, we'll do it on one firewall. Actually, we'll figure something out today. Sometimes when you're not 100% sure, you do something and you just test that theory, not just in networking, but just in security as well. So we know that our management interfaces, this one is the one that we oh, let's get rid of this. We left this open. We did a video where we left this open on the web for 12 hours and we left those checked. But for ETH11, and I didn't like the name, to be quite honest, I'm going to rename this. This is Gateway Load Balancer Health Check. And we're going to open HTTP, but we're only going to allow traffic from this VPC. Then we'll hit OK. All right. And so on firewall A, we should be good. And we typically should write a description as well. But this should probably fail by now. So let's see. Like I said, this takes a minute. So we'll come to our second firewall and we'll be a bit quicker. Let's for the sake of symmetry, we'll just copy this name. All right. So we'll go to policies. Actually, we could do, nah, it's not that serious. I would say we could clone it to make sure that it went right underneath it, but we'll add that. We'll add private, and we'll pick all VPCs, private, all VPCs, And again, this is our, what I like to call east-west traffic, our spoke-to-spoke communications. All right. So we've got that on that side, network, interface management. We'll call this Gateway Load Balancer Health Check. We'll add HTTP and ping. I don't think we need ping, but, and then again, this is just permitting, we don't yet know the IP that the Gateway Load Balancer interface. We'll start seeing it in monitor, to be honest, and we probably see it already as denies. So if we were to go to monitor, get rid of this flag. Yeah, this is the IP of, because again, it's a health check. It needs to make sure that based on those health intervals, if we go back to Gateway Load Balancer and we go to, or actually, I think it's on the target group. It's the health checks, the interval of every 5 seconds. Well, this, and then, this is where it says, hey, if we're going to check every 2 seconds, if it fails 5 times, etc., like, we'll make this unhealthy. But these are the thresholds, not specifically the numbers I gave, but this is where those configurations are happening. But we saw that it's now allowed, it's permitting. All right, so let's go ahead and see if this is done. All right, so we see that A is healthy, but not B. Oh, and see, we did that. We didn't test our theory. I'm thinking too quick because I wanted to not add that interface management health check there. But we've got one healthy target. This one should come up, but we'll keep it moving. All right, so we're truthfully almost halfway there. It took a while to get that baseline there up, but next up, we've got to configure the endpoint service and the gateway load balancer endpoints. So again, if we bring up our drawing, we didn't insert it here. I probably should have did a drawing that showed that, but this is where we've got the gateway load. But if we zoom in just a bit, we've configured this gateway load balancer that's targeting the inside interface of both of those firewalls. But now we need to configure those endpoints that when traffic comes from somewhere else, it will send it to the firewalls for inspection. So this is the piece in the service that we're going to configure, and that's actually underneath VPC. So it will go down just a wee bit. Let's see, it should be right here, and we'll right click, new tab. All right, so we'll go to create endpoint service, and we'll call this Palo Gateway Load Balancer ES for endpoint service, just because we've been using that naming convention throughout the day. We'll select gateway because this is a gateway load balancer. Now we see that that load balancer is available. So we'll select that. Supported regions. We don't need to do any cross regions, so we won't select anything there. And we'll do IPv4 for today, and we will hit create. Now what we need is actually this service name. So we'll copy and paste it into our notes, because now we'll go to, actually, let's see. I don't think we have to, I think we have to wait when we create the endpoints. Yeah, it's available. I was looking for the state. But when we go to endpoints, we'll create two. We'll create one per AZ. So we'll do Palo Gateway Load Balancer E 2A. We'll do 2A instead of AZ1. All right. And then through it, we'll zoom in just so you can see these different selections, but we'll pick endpoint services that use NLBs and GWLBs. Service name, this is where we need that long, it might still be in my buffer, but we'll copy it from our scratch pad, paste it in, and we'll hit verify service, and there, it's good to go. All right, now the thing about it too, when I said there's different ways to skin a cat or multiple type of solutions, if we go back here, uh, you could put endpoints in another account in another region, like etc., and then share through Resource Access Manager or RAM. As long as you have that service name that's verified and you hit those checkboxes to do inter-region communications, you could then, that's how you kind of sometimes design a solution where you don't need to stand up another transit gateway in another region. Uh, well, for inspection wise, or actually you could forward traffic through it, but you don't have to put a firewall like in all these different accounts. And we know security groups is kind of a I won't call it it is kind of a firewall like service. Um, but along like when this was very new, that was something we did for a health client as well. But let's keep it moving. But it's just that you got options, so you got to think about what you'd like to do. But let's stay focused on what we're doing today. Apologies there. And so this one is 2A. So we would select only the 1 and 2A, and this is where we pick the GWLBe. There we go. And if we wanted to give it a specific IP, kind of like we do with our firewall interfaces, we could do it. But for today's purposes, we'll just go ahead and let AWS select pending acceptance. Let me hit refresh. Oh, maybe we picked something where we gotta, let's go back here. I don't remember me selecting like we gotta accept it, but I think it's been a while. I think it's here. So we'll check this box, actions, and accept, and type accept. I don't remember where that default to auto accept. We'll figure that off offline. So that's pending. So we'll come back and create, we'll refresh that, and we'll create our second endpoint. We'll pick this pace up here, Palo Gateway Load Balancer E2B, and then we'll copy this long service name again. We'll select the endpoint services, paste, verify, select security VPC, and then we'll select 2B this time, GWLBe right there, and we're good to go. All right, so I guess we do need to come back in here and let's pending acceptance. Now we'll go here, actions, accept, type accept. All right, cool. And we'll now think about like the thing about some of this too. Mine goes in tangents sometimes. Appreciate everybody sticking around. But when we automate these type of actions and tasks and activities as well, no different than if this was 20 years ago and just doing script and link. We have to account for the API that's prompting us to like enter or accept something or enter a keychain like a password. Like that's the value of a well, let me not go off on a tangent. Keychain. Like when you communicate with GitHub, sometimes when you run Terraform, they're gonna ask you for that password like 100 times, but you can actually use a key ring to not be prompted each time. All right, so we'll go to endpoints and we'll refresh. Now this says pending. This is the part that may take a while. I think it took like 3 minutes. It might take. Okay, so cool. 2A is available. So we're good to go there. So now let's go to X there. Configure gateway load balancer endpoints. We did that. Separate the transit gateway route tables. All right, so let me try to do this ugly drawing. Apologies. I'm gonna get one of those scratch pad one of these days. But we kind of explained it at the beginning. So what we have here, this is very ugly, so I apologize in advance. So again, it should be a square, but we've got 3 VPCs. We got one called security, one called test, and one called prod. Now, by default, like that's why anytime you create any route table or any whatever inside of a VPC, each route table will have that local route that includes the CIDR of I think it's the VPC and not the subnet. It's the whole because intra or inside of a VPC, that communication is I won't say enabled by default, but outside of security group, the ability to forward traffic exists and it's there. But when you need to go outside of your VPC, like we have 3 VPCs here, the way we did it, one of the methods and AWS is kind of preferred or suggested for the last 4 or 5 years is to use the transit gateway. And so we create these attachments and they're called either VPC TGW attachment or VPC. I always get them mixed up, but basically it's basically inside of the VPC there is a route table, But when you point it to the TGW, then that traffic, of course, goes across that attachment. And the TGW itself also has a route table. And by default, if you associate all of these attachments here, then that route table, when it does the lookup, like it knows how to reach, like if test needs to reach prod, and it says, oh, well, just go across this. Well, I should probably do a different color. It says you want to reach 10.0.2.0. Like, okay, well, use this attachment here. And it just forced that traffic there. And as you can see, nowhere in the picture is there any inspection by the firewall. So to be able to decouple that, that's where we need to break up this TGW route table. So let's go back in here. And what we're going to do underneath VPC is, let's see, we're going to rename this one. This one, of course, has all three VPCs associated. Let's see, not to say easy way. I guess the easiest way is to remove one and name this, but we're going to rename this spoke route, TGW route table, I guess technically. All right, and so now we need to find either the attachment ID, well, which we will just come up here. We'll come back, but the attachment ID for security. Oh, we didn't rename these. Yeah, this is where. All right, so see, we we didn't rename everything. So this would technically be prod. All right, we'll fix it though. And then security is security. Apologies there. We tried. There's so much configuration that I tried to do in last night, and I had an exam this morning, so I didn't even get back to finishing it. This will be tests TGW. All right, cool. So we need this TGW attachment ID for security. And if you don't believe it, you can actually just go to, I think there should be VPC ID. Yeah, you can go to this VPC ID and say, is this really security? Like during that renaming that I just did, it was wrong, and it is. So we picked the right one. So now the ID that ends in 516, transit gateway route. We'll open a new tab. We're gonna remove that one. 516. All right, so this one will come to delete association. This might take about 10 seconds, maybe. All right, cool. Big shout out to everybody again. Hope everybody out there is having a pretty good start to their New Year's. But while that's doing it, again, really the end goal is on this next slide. Like the one that has two associations for our test and prod VPC, we're basically saying to reach anything, even another VPC, you have to go across the security VPC's attachment. And then once it gets off of that VPC attachment, that's where the route table says, go here or there. Then that second one that we're going to create is for the security one that we just removed. It needs to know how to reach the individual VPCs for the return traffic. So that's really what we're doing. Let's see, we'll refresh. All right, so it's gone. So we'll change routes and we'll just basically, I wish you could, I don't think you can select more than one at a time, but yep, that's something they need to fix as well. Well, then again, if you mess around and in production, but hey, why can we not? We should be able to. Let me just hit refresh because this is a bit weird that we can't remove the routes actions. Oh, never seen this before. Let's go ahead and delete this as none. This is kind of weird. You should be able to remove a route. I've never seen this. Uh, hmm. So the quicker way is not quicker. Well, we're going to just have to build from scratch, which is cool. So let's go ahead and delete this association. Apologies there. I've not seen that before, to be quite honest. All right. So while that's happening, let's go ahead and create the second one that we'll just call security TGW RT for route table. And this will be associated with that. The only TGW we have, it's pending. Let's make sure these are gone. All right, so those are gone. So, wow, that is crazy. Why? I've never seen this. To be honest. All right, so all right, well, there's nothing associated, so we're gonna rename this one. We'll just call it Foo Bar. We'll just create another spoke TGW RT. And we'll of course associate that with our only TGW. We're kind of almost there. Like I said, like how long we been in this one here? Maybe 30 something minutes. I don't know. Oh, now I lost 45 minutes, lost track of time. All right, we're getting there. Thanks for everybody for hanging out with me today. All right, let's see. So that one's almost ready. But while that one's coming up for the security, let's associate and from here you can kind of see the names and the IP, so no need to go look it up. So for this one, we'll pick security. We'll create that. And there we go. And so for the routes, this one, of course, like we said, it needs to know how to reach 10.0.10/24, which is test. So we'll select test, create static route. We'll select security one more time, routes, create static route, 10.0.2.0/24. And then we'll select prod. So one half of that is done. Let's just make sure associated is good. Routes are coming online. There's the second one, good to go. All right, so now we go back to spoke and we need to associate the remaining two. So we'll do tests, association, highlight, create association, and we'll do prod. And like we said, we're going to send all or force all traffic to go through the security VPC. So this will be a quad 0. We drop down, started typing. Cool. And we'll send that all across there. All right, so that step is done. Let's see. Another one. And then security TGW VPC attachment appliance mode. This is kind of to force or to try to keep, by default, it'll try to send AZ traffic 1 across AZ2. There's ways we'll test it in a future video. We'll demonstrate how, like, let's say you need to perform maintenance, like upgrade the software on one of these firewalls. Like, how do you ensure that the traffic that's currently going through it or the sources still can route out across the other gateway, which it's called cross zone load balancing. But for now, we will go to this. Let's see, we'll go to that attachment. We'll go to actions, modify, and we'll check this box here. Now, just to show you, which maybe like it is extra cost to route across AZs. But if we go to our load balancer underneath, I think it's attributes. This is where that cross zone load balancing, and you would just hit edit and hit that. For now we'll uncheck it. But all right, so that step is done. All right, kind of got about 2 more steps before we test. So it says or I've said to go to the CLI and perform really this one command. So right now, these packets that are coming across, I think we're still logged in. These are just health checks. But oh, that's I'll say that's one of the servers trying to. I don't know why it's reaching out externally for NTP, but But when we start sending these pings across and for that traffic to be inspected, to de-encapsulate that Geneve protocol and to know that what to do with the traffic or, to technically inspect it, it's basically think of it as an on and off switch for the firewall, whether we want to enable that inspection or not. This is a newer computer, so I don't have the my favorite MobaX term. So let's just go to command prompt. We'll bring up 2 CR. All right. And I probably should have wrote this down as well. All right, we got 2 up. So we're going to SSH into both. And we'll keep them both up for when we get to testing as well. All right. Shout out to my Mac users as well. Nothing against. I got some Mac behind me that I don't ever turn on, but unless we need to test a feature with it, um, but I'll go to that dark side one day. All right, so we need to SSH in. We'll zoom in, but we need to get our data plane IP addresses. So let's go back to instances. We should still be on the network tab. So for 2B index 2, this is what we want. So we got our scratch pad here. We'll go ahead and we'll just say 2B our firewall 2. Not that we should know, but we won't. We don't really need to look at this but one time. Then we'll select 2A. Again, thank you all that just dropped in. We're almost done configuring this. As you all see, it does take a while. Um, there are a lot of small steps that you can foobar over, and we're not over the hill yet. We have to test, um, keep our fingers crossed, and troubleshoot whatever may come. But hopefully, we should be good to go. All right. So again, we configured this stuff the other day, and when you get on a live stream, stuff is like doesn't want to work. But I think we'll be good. Let's get her done. All right. So we'll CD into downloads folder, SSH. Let's do what's the first one called? AUE 1, 2 tests. Uh, Tests. Let's do. I think we made that port 2222. EC2 user for AWS Linux, and I can type this 3.151. All right. And oh, hold on. Oh, my bad. My bad. I'm getting ahead of myself. Oh, slow. That's the data plane interface. That's oh, we'll keep it there. That's when we get to here. We haven't configured the route tables yet. We need to just get to the management. All right, my bad. So for that, we just come up to here and do. We'll just copy it. Man, I'm all right. Cool. All right, let's go back to A. So we just need to do SSH dash I. What do we call these? Palo P AZ1 admin. All right. This will be yes. All right, cool. So this command will make this a wee bit smaller to focus. All right, so let's do the show command first. Actually, let me see. I don't know what. Let's see. We'll see what this says. Okay, so gateway load balancing is not enabled. So again, like I said, this is kind of like a light switch. This is how we turn that on. And unfortunately, you're not able to do this in the GUI or the console. There's a few things that appliance mode you used to not be able to do in AWS. Is you had to do that CLI as well. Maybe you need to be in configure mode. Ah, let's see requests. Maybe that ain't it. Let's see plugins. Enable. Did I not type that? Oh, yes. Left off the yes. All right, cool. So we'll hit up a few times. And let's do that show command again. All right, cool. So we saw that it was false before. If we scroll up, and we're all good and all set now. I think we just need to commit. Let's go to configure, but this doesn't require a reboot. So we'll just add yes to the end of that so that when we come to our second one, close. All right, so we're almost there. I'll speed up the pace. I know I've been explaining and slowing down a bit here, but I know some of y'all getting tired. It's a Saturday, like I said. So thank you all for hanging in here with me. We'll CD into downloads, and let's do SSH -I was PA Z2. This will be admin, and then this IP, and I will do the same. Let's prep the copy of the command, but we'll do the same. We'll do the show. Make sure. Although we just configured this one. This one is way. Ooh, see, it's got some CA bundle. CA cert. I know we're starting to get a lot of these messages about. I don't know if it's a certain part of the chain. Maybe somewhere in the middle is. I don't think the root is changing, but maybe that's what that's related. Oh yeah, because we deployed the other one in the summer. This one we just deployed a day or two ago. Sorry, thinking out loud. I try to think things through. All right, cool. So we'll do that. Oh, we what is that? Oh, well, we might have some that's very weird. We need to look into this. The system is going down for a reboot. Wow. And it didn't. Strange. All right, cool. So let's go back and see. Actually, it's rebooting. I think we didn't ever see if the B side ever went healthy. So we'll need to troubleshoot that. All right, but let's do the routing while that unfortunate reboot. And as you all saw, we didn't get that on the A side. All right, so we might need to look into this CA bun Etsy, CA cert. This device. Is it? It's rebooting already. Okay, apologies there. We'll keep it moving. So the last thing that we need to do, other than get the B side healthy, is to configure, which we don't have a slide, but when we get here, like there's some changes. Like right now, I think what's happening without looking. Like I said, apologies for these ugly drones. We'll get rid of this. Let's see. How do you make the pencil a little bit? Is this it? Make it. Oh, that's terrible. Let's go smaller. All right. So really what we have right now, we'll go right to left. So when test wants to communicate, and we just configure that gateway load balancer. So once it comes, actually, all of its traffic goes across this VPC or TGW VPC attachment. Cool. And we just configured that separate route table that says for anything that's coming from test or prod to send it all to the security. So again, likewise, there's a I won't write it all out. There's a TGW VPC attachment here as well for the security. And what we had before to route this traffic, let me make this a little bit smaller, is we had a firewall in 1A and a firewall in 2A. So inside of the VPC route table, what we had is that we pointed traffic for the 2B towards this inside. It's called an ENI, Elastic Network Interface. And then for the 2A, we did the same, but we pointed it towards there. So traffic, the key is that traffic, we now added, the gateway load balancer is not important in the flow of routing. It's really important for the health checks and to pass that subnet. But we've added this gateway load balancer endpoint, and we put one down here and we put one up here. So we need to somehow get traffic there so that we can force traffic to basically be inspected. So that's the key. And the way that we're really going to do that, long story short, is we're going to do our TGW is going to basically point any traffic that needs to go 10.10.24. We're going to point that to the GWLB for the specific AZ. Then likewise, we're going to do the same for this. Ensures that any inter VPC and this small proof of concept, this 3P VPC design is going to be the same. And only this quad zero, like technically, well, we'll see. We'll see. I should have put flow logs on. Had this weird thing like a few months ago where traffic, we'll see if traffic is getting natted, but it was somehow without enabling actually no, yeah, without enabling X forwarded 4, traffic was making it all the way to the back with the public IP. And so for the return to know how to get back to the host, we needed to, I'll put a star here. We needed to add this route that sent it to the outside interface of the firewall. This in production definitely isn't needed. We'll have to troubleshoot that. So that will get it there. And then the gateway load balancer endpoint automatically is kind of synced. It's all because of that Geneva protocol and because it's associated. When we saw those services in the VPC, we made the endpoints and we did that service name. That's the power of where it's almost glued together. So anything that it receives, it's going to send it to the gateway load balancer that's distributing traffic across the firewalls. So we don't need a route going towards the firewall. But when traffic gets inspected, let's say it's permitted. When it comes back, it's going to come back to that gateway load balance endpoint because of the way of the source IP, hop by hop. But we need to know how to get traffic back. So they actually need a route. They need these same two, but they need to point to the TGW. And so we should be in business after that, to be honest. But that'll be kind of near the end of our video today. All right, but let's go ahead and get that configured, and let's let's see if this crazy firewall came back up. Let's see, because I do not know what that bad boy was doing. We'll just copy this command and run it again and see if that really did enable it. It is enabled. Okay, well, I guess we're good there. All right, so let's keep it moving. So we'll go into we'll modify. We don't need this. We don't need this. All right, let's go to route tables. All right, so we'll sort this and we'll say right now our security, the border router is the equivalent of that transit gateway attachment. It's sending traffic to the ENI, but we need to change that and say add a route for anything that's 10.0.10/24. Let's do, we'll send this to the gateway load balancer endpoint, and this is 2A. We'll do the same for 2. Mentally, I'm just walking the packet from the spoke here. Gateway load balancer endpoint, still in 2A. We'll remove this. All right, so we should be good there. We'll go back to route tables and we'll go to border B. We'll similarly do add, I guess I could have did there, 10.2. But this time we'll select Gateway Load Balancer Endpoint that's in 2B. And the same here. I should have enabled flow logs too. Yeah, the thing about it is I didn't really, not to say test it, but I didn't configure this. I didn't configure this beforehand and make sure it was all good. So that's why we may have some troubleshooting, but I think we should be good from doing it like a month ago. All right, let's see. All right, so that's that. That's the TGW. Now the gateway load balancer endpoint, we said for the return, they need to know. We could have actually combined these as well, but they need to know how to send that traffic back. All right, so we're almost ready to test. This is the last step other than checking the state of why that second one wasn't healthy. TGW's actually, let's do this. I was gonna say let's just combine them, but we'll just keep them separate. Like I said, sometimes in the future in production, like if there's a reason that which for this one I won't say what there shouldn't be a reason that you need to influence it differently, but maybe they come out with something, uh, add a feature to it. All right, so that's good. Let's go back here. Let's refresh. Unhealthy. All right, so this is our B side. It should ask us to log back in. We'll just refresh. Once we log back in, the last thing is we just need to get that second endpoint healthy. And we're almost wrapping this one up. Like I said, I'm sorry that this one's going a little long. Ooh, we're at 120. All right, but what we're trying to do now is troubleshoot why the health checks are failing to our second firewall. So let's see, we got that's gonna be 8080. It's allowed, it's hitting a rule. We did configure that east-west rule there. Cool, cool. I think we did that object as well. We did network per minute ping HTTP from 10, which should have been the same as here. Yeah. Traffic is there. So we don't need flow logs because this is a direct kind of connection. Let's go back here. All right, cool. So 10.0.0.150 registered. All right, let's make sure that's the right IP. Just mentally troubleshooting this one. Index 1 is inside. 10.0.0.150. 10.0.0.150. We shouldn't have to deregister now. I'm just mentally thinking of the flow, which is direct. There is no route table lookup here. Port 80. Monitoring. We should have one healthy, one unhealthy. All right, let's go. Let's take a look though. Gateway load balancers. We put them both in the same route table, and they just need to be able to reach the inside interface, which is that default local route. So A to B, the middle is good. The firewall's inside interface permitting, that should be the same as well. That they should have the local route, inside interface security group. That's the only other place I can think. All right, let's go back to instance. Let's go 2B security, inside, right click. Sorry, just troubleshooting this last thing. So it is permitting this as well. So it's not a security group issue. Let's just deregister and unregister and probably keep it moving, but and that way we can see how to do that as well. If we go to targets, register, which this shouldn't be a fix, to be honest. We'll go to cancel 10.150 deregister. All right. Direct. Let me look at the chat. Oh, let me see if somebody in the chat is saw something or whatnot. All right, so we're just gonna try to bring this one up. But while that's doing it, technically, I guess we should be able to test the A side. So we had the so we're actually ready to test once we get that up. So Gateway Load Balancer is enabled on both sides. We configured the route table. All right, let's see. We are in the firewall. Let's exit. Actually, I should have pinged the actually, let's go. I was gonna say I should ping the server from there, but let's just. Oh, we're still in it. So let's see. Ping host 10.0.1.50. All right, so we can ping the server. How about 2.150? We can ping both servers from the firewall, which is good. All right, let's go. That command that was the data plane was this one, I think. 160. Yep. Let's see. So oh yeah, this is a weird one too, where we need to get into the box with I'm trying to do it still using the firewall, though we got different ways we could use the SSM agent, etc. To get in. But let's see. That may be where we need. I should have enabled flow logs to see if that traffic is hitting the backend server, but technically we should be able to go in. Let's see, monitor. We'll just troubleshoot this real quick. So it should be this packet. Let's see. All right, so NAT supplied, destination IP. This is that weird problem I was having a few months ago where it wasn't showing the NAT though. It's hitting the right rule. It says it's performing NAT, but it's not giving us that destination. It should be the private IP for that NAT rule that it's matching should be there. And that's a fluky one. All right, so let's see. And this is this is the A side, last hit at 1325. So it's hitting that NAT rule, which is translating to that. I think it's doing that weird thing where for some reason it's going around and the public IP is making it all the way to the back. I'd have to enable flow logs offline, but like I said, I don't want to, that'll take a bit more time. So what we're going to do is do that part that I said we shouldn't have to do for the transit gateway security. It's called border. We're going to add a default route for all unknown traffic. And this is the A side. A side, we'll send it to the outside of 2A. Let me see if this works. We'll stay on the 2A. Some wonkiness. All right, but we're almost getting there. Thank you all for hanging in here today. Like I said, we'll give this another 5-ish minutes. I don't want to hold folks for 2-3 hours, but we'll probably hit record and troubleshoot and keep troubleshooting, but post the fix offline. All right, so we got that, but because we really do need to get this one. Wow, still draining. So if this was production, wow, we don't even have true traffic coming through this to drain. But I wonder if it's because we made these, I won't say too aggressive. I don't know. I gotta look into, did these correspond with the deregistration times as well? I don't think they do. All right, so that's gone. And this was so what are we doing? Registering, I think it was 150. All right, we'll add, make sure one more time. 2A networking. All right, let's see what we got. Index 1. Oh, 2B, sorry. 150. Yep. All right, so we got register, cool. So we'll see if that registers it there, but that shouldn't affect the B side. But I do want to see what that traffic looks like. I don't know. Tests. Let's see. Oh, we do have flow logs already. All right, well let's check them out. This might be from the summer. I just want to see what that traffic that's hitting it looks like to make sure it's oh, nothing's there. Let me see. Test, which is weird. Let's see. Access error. Flow logs row. Looks cool. All right, so let's just create a new one. All right, so we'll call this one Gateway Load Balancer flow log. And let's choose a log group. We'll just send it there as well. Service. I'm assuming the assuming that row has the proper permissions. All right, let's just create a new one. All good. So this will have to wait about 2 or 3 minutes. Like I said, I won't hold all of you guys that are hanging in here, but it's 1:30. What I'm gonna do is I'm gonna keep troubleshooting. I'll probably stop the stream and then with a Camtasia just hit record and publish the video shortly thereafter, but just to keep troubleshooting. But like I said, I want to thank each and every one of you out there for always rocking in here with us. This was a great demonstration there. Gotta get, it's just probably another 20-30 minutes and I don't want to hold everybody. But this was a great first live stream. Like I said, let me know, not in the chat of this live stream, but in any video, if there's any topic or anything that you guys want to see. Just straight up talk sometimes, or to see configured or anything like that. Would definitely love to hear from each of you. Wishing you all the best in this year, and hopeful to see what's ahead for all of us here. But like I said, until next time, stay safe, take care of yourselves, and peace. Thank you all so much. I appreciate it. All right, so yeah, we just ended the live stream, but we're just gonna keep pushing. Like I said, I appreciate we got to about an hour and a half, and I just didn't want to hold everybody. So I'm gonna just keep pushing and record or upload this as a separate video. All right, so let's see. We got, yep, screen's good. Hopefully it sounds good. And let's see. All right, so we're trying to get that second target healthy there, and we configure the flow log to see on the back end what these SSH attempts, where they're hitting. Let's see, because this didn't time out. We see it in the firewall, so we know it's making it there. We got in the firewall, we know we can ping. The ping's not always the best source, but it's a good start that we can successfully ping the two backend servers. So I'm thinking that middle part is good, but there's some part what I truly think is that the NAT that we see here is, for whatever reason, I think the backend is seeing our public IP. I've seen this problem before And these are allows. See how the NAT destination here says the server, like that should be happening. And when we tested, we just stood up the server and basically got in. That's the extent of it. We didn't fully configure any of this gateway load balancer ahead of time, but that's what we should be seeing. And I think because we've added or inserted that gateway load balancer, something's happening. We have to figure that off offline as well, to where I think like it's an exported for type of behavior. But let's keep pushing. We don't know how long this will take. This is just troubleshooting. This is what happens in production. All right, so we got two problems. We need to get the second host healthy, and then we need to see what the backend is seeing. So we just configured this flow log. Let's get out of there, and let's open this destination and see if we're logging traffic yet. Sometimes it takes a few minutes. Uh, Oh, I didn't even create that flow log. Successfully created flow log. This, I know that may take it. Normally, this part doesn't take that long, but let's see. Does not exist. Doesn't exist, so we can't tell. It makes sense. All right, let's just create a. Let's just call it that. We'll do Monday. All right, so let's just do it backwards. We'll create the log group first. Although this is very odd. Let's go to your VPCs, tests, flow logs. We've got two created, so what's the point? Very odd. All right, so all good. Gateway Load Balancer POC. The defaults are good for that. We don't even see. All right, there we go. I was gonna say the one we just created. We'll start typing flow logs, and let's do. The last thing is just to check the permissions on that, but we should get a failure if it doesn't have, or one would think we'd get a failure if it doesn't have the proper permissions for this role. All right, but let's go back in here. We'll refresh. And it definitely won't start popping up stuff right away. We'll have to. And so what we'll do is we'll actually get back into the firewall for temporarily, and we'll just send pings to that VPC. Although the NTP and those type of traffic should populate as well. 10.01.50. All right, so we got that going. All right. All right, so we'll wait and let's get. Like I said, we got two problems, so we got troubleshoot two. So what's the deal here? All right, so AZ2. We enabled the inspection, but we got this weird error. It rebooted. System's going down for reboot. All right. Let's see. All right, so we got pings. All right, we are in. Gateway load balancing is enabled. All right, let me think. All right, so let's go mentally. So there's two parts to this. So the load balancer is the load balancer. We pick the right AZ192, the subnet AZ2. Make sure. All right, this would be Gateway Load Balancer route table, which is local, which is cool. NACO by default permits everything. All right, so we're good there. All right, so we're good there. This should show the... All right, that's cool. We didn't enable cross-loan. That shouldn't have anything to do with this, but let's just enable this anyway. Say, all right, so let's go to target group. All right, so still unhealthy. We unregistered it once and we re-registered it. I think we're doing port 80 TCP. All right, so those are the only two. We checked the security group for the inside interface. All good to go there. So the firewall, what would be here? We see, all right, we see the health checks coming in. Let me see, are these aging out? I think because we don't have a specific page or a response. Oh, these are actually TCP fins, port 8080. All right, so all we did was a permit internal private all IPs are all in the VPC. We should have the similar traffic here. Private all, and it's allow. And we're getting hits. We're matching the rule. Objects. Let's see. Nothing object network. Network. Network has the LAN. Network shouldn't have anything to do with it as well. Actually, yeah, this is just the health check, not the gateway load balancer part. They're in the same VPC, different subnet. All good. Let's go back. Let's see. Yeah, 10.0/8 goes out ETH11. That's correct. All right. So let's see if this firewall, although this isn't this traffic, I'm just curious. Ping host 10.0.1.50. All right, so that middle part looks good. Looks good. All right, cool. Let's see. All right, so Gateway Load Balancer Endpoints perspective, and we got. All right, so we got 2B. All right, so we got that. The only other thing, other than a policy, we're permitting any there, any. The application default wouldn't matter. Oh, that's okay. I was gonna say maybe we didn't add. Let's see, address group. All right, so we got 20. Actually, this is data plane. We're just talking about health check. But I have to mentally think both through, just troubleshooting. All right, so we got monitor interface, gateway, ping, HTTP, because we did port 80, permit IP 10.0.0.24. That's all that you need. Ping, HTTP. Oh, wait, maybe we didn't apply it. Actually, let me not. All right, so we did ETH1. We didn't apply the management profile. All right, so we'll add the health check there. All right, cool. Mentally walking this through in my head. Okay. But the cool thing is, like early in the live stream, I did say I wanted to test, is it necessary for this specific config? Like I said, in production, like the first time I did this was, it felt like 5 years ago with Ventec Solutions. And I think we did port 443. But also we did that interface management swap because at the time, um, the Geneve needs to be able to speak on a data port, and the first interface is people typically use it for management. So there's a CLI command that swaps the interface, and ETH1 and 0 will flip flop so that ETH1, which we have inside, will become the data plane, and index 1 will become ETH0, which is the management. All right, cool. So that's that. All right, so I think we got 1 out of 2 problems. Let's check these CloudWatch logs and see if we ever got any. No streams. No streams. Very weird. I don't like that. I'll have to look at the row. So let's see. Not that we need to see traffic here. We need to make sure it's leaving, but yeah, we didn't ever enable it or configure it here. All right, so let's think. So we'll scratch 1 out of 2 of what we need out here shortly. All right, let's get it. Probably it might take a minute or two. Maybe it'll be, there we go, healthy. So that was pretty quick. All right, so we got 1 of the 2 problems. Now we need to actually SSH into our box. I mean, we could skip the step and like put SSM agent and just connect, but I kind of don't want to do that because it's to accomplish what we needed to do in the video. It will get us there, but if we encounter a problem, I kind of like to fix it, even though this isn't production. So all right, let's go. Oh, that's right. We need to get out of the firewall control. There we go. All right, so we need to be able to SSH AUE2 test 1 Linux 1 port 222. So that's the A side. I wonder if the B side can hit. Where's our notes? Let's do SSH dash, all right, relax. SSH dash IAUE prod dash P 2223 EC2 user at 18 218 57 53. Let's see if the B side can get over there. All right, so we're down. So I think it's going to be a return path issue, to be honest. All right, so let's go back to our route table. We're partially blind, and I should spend the time to get these flow logs up to know for sure without guessing. But let's look at these route tables one more time. All right, let's look at, all right. So I assume traffic's making it there because the pings can. But I think, like I said, all right, let's follow our hunch. Transit gateway route table. So we did this thing. For some reason, we cannot delete this route table, I think. Well, actually, maybe we can. Actually, we can. All right, that way no one's. It's set for as default. Oh. Oh, well, let's see. How do you see? How do you change that? maybe you need to unseat. One would think they'd have a actions managed, but I don't see it. But that's cool. So we don't have any associations there. All right. So we did our spokes and we did the two and we sent everything. We sent everything. We sent everything to the security VPC 516, which this one's associated with, and then the routes know how to do the return. The middle part has to be working because the pings can get there. So I don't think we need, well, I know we don't need to look there. It's gonna be something here. Actually, the other thing could be, let's go back to instance prod Linux. Actually, if the NAT is wrong, we did a permit all. All right, so that hunch isn't there either. All right, let's go route. Let me think. Route table. Route table. All right, so on the return, we say that when you come across the security border, VPC endpoint. So on the return, here. Let me think. So we're saying it reached 10, 1, or 2, but this one. Oh, so if we hit the SSH, we master rule, we go out the inside interface, then we have to hit the TGW VPC attachment, which is this. To get to 10.1, we'd hairpin back for inspection. That's not what we want for these inbound SSHs. Let's see. Actually, you know what? The logic is wrong. I think. Why did we send it? Yeah, we need to send it to the inside interface. All right, so security gateway load balancer endpoint border subnet. I'm used to these saying TGW. Let's edit. All right, so quad 0. Let's do AZ1 inside save. And let's try to test. Yeah, I forget which one's the A side. Let's just do both and we'll test both. All right, let's see. B side, routes, edit. We didn't even add it here. 0. Yeah. Network interface inside 1B. AZ2. All right, so let's try to test it now. All right, so this will be 223. I think we tried to do the B side. Let's do the A side. Oh, okay. So that was just the logic. All right, cool. So the A side and then the B side. Now, what's up with the B side? All right, so the B side is. I'm not trying to ping. 223. Did we write that? 18 to 18. 57, 53. Prod, and then 223. All right, so let's see. Ping A. So we'll do 10.02.150. Can you ping that now? It can. And then do we see it in our monitor tab? So we'll now change our filter to source 10.01.50. Ping, permit, no NAT, and destination. All right, so cool. So we're getting what we want. So we'll hit. All right, so we got the A side and we got the B side. Not sure why it took so long. So let's see, can we ping the other way? 10 0. From prod, can we ping? All right, so we got what we needed. It's 156. I guess if we'd have stayed on that live stream another 20 minutes or so, we'd have been good. I apologize, but like I said, live stream was getting long. But now what we're going to basically demonstrate is that what we can also do. The cool thing, we didn't talk about it, but now we have visibility into this traffic that is flowing east west. Like we said, without these rules, one VPC is able to almost, it's not directly, but it's almost directly to communicate with another VPC. But of course, it has to traverse the transit gateway. And then that's the route table it looks at. So VPC route table says use this link, this TGW VPC attachment. The other end of that link is the TGW. The TGW has its own route table. And by default, or with just one route table, it says, well, I know how to reach prod, so go across that. And so that's what we mean by it's almost directly communicating. What we've done here by basically splitting up these two TGW route tables, if we take a look here, uh, uh, yeah, I, like I said, if you were in a live stream, you just saw this foo bar is just foo bar. But we basically put each of the two spokes, which are test and prod, we associated them here and said all their traffic has to go across the security VPC. And in the security route table, our second one, we only associated that security VPC and it needs to know how to basically send the return traffic back. So we're good to go there. But the other thing that we can also do is if we go to policy, let's say we want prod to be able to talk to dev, but not dev to prod. We can put a rule that's above this. So we'll just say clone. Okay. And if we had panorama to centrally manage, it definitely would be easier. But we'll call this deny test to prod. And we'll just do one way and kind of end the video here shortly. So the source, of course, is going to be tests. Did we say dev? We meant, yeah, test to prod. And the destination will be, oh, we didn't change the VPC. Security tools was prod. Source ad. We could put the whole VPC, or we could just pick either or. We could say one server can't talk to another or anything in that. We typically do the infrastructure. So let's do, this one is called test VPC. I don't know why we didn't rename the security. It's kind of confusing. And the action will change to deny so that we can log it. But let's go in here. Let's change. Call this prod 1, 2, 3, 4, 5, 6. Apologies there. Did a lot of troubleshooting on that call. All right, so we'll hit commit. And again, for both firewalls, I mean, because we're load balancing across it, for the most part, we'd want very similar rules. I mean, if we had global protect or I won't, one firewall had a zone that the other one didn't for some special mission or whatever. We of course want them to kind of be somewhat, I won't say symmetrical, but the policies are roughly almost be 100% the same, because if we do cross AZ load balancing, or if we need to take one down on the other, we need traffic to be deterministic and to flow the same. And so that's our desire and what we would want to be there. So let's actually see if the ping will go and stop. Maybe we should have kept it going. This is a server Linux, not a, okay, see, so we're not able to ping, but like we said, our desire was that prod can still ping test. So that's what we've demonstrated. And what we achieved really was the ability to now be able to, it's a lot of things. We can inspect traffic, the east-west traffic, not regions, but traffic from one VPC to another, inter VPC traffic has to flow through the firewall. Based on the rules and the matches, it's either permitted or denied. We could have did drop or whatever, but we want to see those rules in here. I mean, the hits and whatnot, the matches in here. We also gained the ability to load balance the traffic. The gateway load balancer is a load balancer. So if we needed to take it down or if one of these becomes unhealthy, hey, traffic keeps flowing and we don't need to really even need to like do anything. I think if we were if we were technically doing maintenance, what I would do is I would come in here and like when I did the announcement and I started doing the software upgrade on firewall A, I would deregister the firewall that I'm upgrading first, make sure that all the traffic is flowing through the other one, and then upgrade that firewall, bring it back online, and conversely, then do the same for the other one, drain that one, make it unhealthy, and then do a software upgrade on that one to go from one version to another. So we accomplished a lot today. Like I said, ultimately, again on the live stream, we had this presentation here. If we go from the beginning, and what we had is we started with a simple three VPC. Let me go ahead and 1 second. Let me hide myself. All right. Hopefully you don't see that. All right. But what we had here was really three VPCs. We started with just, I won't say basic, but the transit gateway in the middle and the routes pointed to the inside interface of each of these. What we wanted to achieve and what was required, you see necessary here, is we needed to split the logic in the middle at the TGW. We needed to be able to influence and force the traffic for each of these associated VPCs to go or to come across the security VPC for inspection. But not only that, we also needed to add something else, which is the Gateway Load Balancer Endpoints. That's the key and the critical component to be able to force that traffic to come into the firewalls. And of course, the load balancer, the Gateway Load Balancer, is what can load balance traffic across a pair of Palo Alto firewall. It actually does other appliances. There's a list back in the day. We used to Google what firewalls, like when we're doing, I forget the word, when we're evaluating different vendors, but we needed to ensure that they also were compatible with not only the Genie protocol, which I think is open standard, but with the Gateway Load Balancer. And so that's really what we achieved there. So again, I just want to thank each and every one of you again. Like I said, I'll do this again for those that hung around. January 3rd, 2:04, we officially, well, about 2, 3 minutes ago, we officially finished configuring that Gateway Load Balancer. Like I said, we ended the live stream there after about an hour and a half. I said I'd continue to troubleshoot offline, and that's what I just did. And we finished her up. So thank each and every one of you for hanging there. Or if you coming in on this video, I don't know what the heck's going, and definitely catch that live stream video right here. And like I said, let me know down in the comments if you enjoyed this or you want to see anything configure live. Would love to get your valuable feedback and do more of these live streams in 2026 and beyond. Thank each and every one of you out there for always rocking here with me. And until next time, stay safe, take care of yourselves, and peace.